Okay, good afternoon, everyone. Thanks for joining us. I'm going to be discussing the evolution of technology in Canopy Control Training today. But I'm going to start off with a little bit of a poll situation, try to kind of place everybody in terms of their experience and exposure to technology throughout their jump career. How many, by a show of hands, how many people in the room landed their first parachute with the assistance of a guy on the ground with flags in the air, holding up, telling them which way to turn? Yeah. Everybody look around, take note of the hands, right? Not to point out the older gentlemen or the ladies in the group, but I was one of these individuals as well. And of course, I don't know if everybody had this experience, but I overflew my flag guy. So I landed the first time ever looking back over my shoulder, waiting for him to tell me when to flare, which is a little bit of a eye-opening when you think about what we used to do. Okay, next question. Show of hands, how many people made their first jump guided to the ground using some form of radio comms? Hands up, please. All right, now everybody take a look at what's changed. It's a lot more people, right? So this represents a step in technology that happened, so we'll come back to that. Next question, how many of you made your early jumps with some exposure to, let's say, Google Earth or satellite imagery in the planning elements of their first jump? By a show of hands? There's one guy in the back, okay? All right, next question, show of hands. How many of you made their first jump and used virtual reality as a part of their solution or their training education? One guy over here, okay? So we're starting to see some trends, okay? And then the last question is, how many of you had no help at all? Good, yeah, you just on your own, right? Just figure it out, right? Okay. All right, in the near future, these responses will continue to change as we evolve as a group. Okay? So let's ask ourselves some questions. Big questions, right? What are we here for? We're going to examine technology and how it's continuing to influence our world in every aspect of our lives, including parachuting, and how we have become better pilots over the years because of it. And we're going to do this by asking ourselves of examining this timeline of technologies together and noting the learning curve that's been happening over the ages, okay? And what that learning curve represents to us as a group in terms of safety and these kinds of things. Why are we doing this? If we look at these trends in technology and realize that it has been making us safer and better pilots as we go, it can continue to help us and guide us. Okay, so those are our big questions for this group to consider. Let's take a look at that first technology we discussed that kind of hit the market, radio systems. It's a technology, it started to become reasonably priced for sport drop zones, to invest in student-instructor combos and do ground-air communications. We got rid of the flags. That created a huge jump in the ability for students to be guided and into the holding area, their pattern, even their flare, unless they're looking behind them. It's a little bit challenging, right? Remote control students and that learning curve related to radios and their use started to become a problem, though. The students weren't really learning anymore. They're being told what to do. And so that's kind of a unique principle, right, that we need to understand is as technology advances, how do we use it? Okay, big thing there. It was amazing, though, a guiding voice for those first jumpers, novices that needed that voice in their ears telling them what to do. Okay, this radio technology translated over into the air-to-air arena. As Canopy skills and different disciplines developed, the radios translated into the air. The military's been using them forever, but that gives us this opportunity in the Canopy Control Training arena to give direct feedback as things are happening, as you're descending on the jump, and provide learning and development in that way. The experience that Flight 1 has had has been an incredible steep learning curve for the students because of that technology, and we spent about 15 years trying to figure out a good solution, And we've got one that's very robust. We make thousands of jumps a year on it, and it's a really good tool set for us. It's allowing us to do team flying on the sports side and the high performance side, and it's helping us to guide the stack flying arena on the military side of the house. So again, why are we using radio systems? Because they allow us to communicate and accelerate the learning, right? And we get direct feedback in the moment of what is happening, okay? So let's look at the next evolution, camera systems. Camera systems may seem like fairly basic. We've got them in our pockets now. But the original introduction of the ground-to-air camera system became a huge tool in landing debriefs. It allowed us to analyze the development of new parachutes, the skill set of the jumper in terms of the flare technique. It basically become every Canopy coach's primary tool that we're offering to the student. And that camera technology translated as well into the air-to-air arena. So we are able to record experiences in the air, bring them down to the ground, debrief. And the why here is a no-brainer. We get a direct feedback loop where we can do slow motion review. We get this cause and effect between what the student did and what the results were. And we're able to, more importantly, pinpoint the exact area that they need to improve, the flare, let's say. If they're coming in on their final approach and they're making all kinds of corrections, the flare, the airspeed is going to be affected, and we can isolate that and show them your flare was not the problem. Your problem was everything before that. And they might not realize, they're just going to focus on the accident, the result, right? So that's a huge advantage in the coaching experience for Canopy development. Next technology, digital altimeters. Everyone knows that analog to digital jump that happened years ago and what that represented in terms of accuracy and fidelity. So that's the why, the big why behind digital. The other big why is this idea of passive feedback from the inclusion of Canopy alarms. All right, we had free fall alarms forever, but I remember in our early factory team era age, when these digital altimeters entered the market in our relationship with Alti2, we said, hey, Roger, could we bring those free fall alarms down into the Canopy experience? And he was like, no problem, it's the same technology, let's do that. So it became this huge advantage for the high performance pilot to be able to not only know where they were in space, downwind, base, and final, but these competition turns were happening so high that the ability to judge altitude accurately without additional information was a huge jump in terms of our ability to be repetitive and get consistent performance, and then train and translate that over to our students. All right, so huge jump there in terms of the use of altimeters and their digital fidelity. Okay, next technology. This is where we started to see like less and less people being exposed to this. Google Earth is now in our pockets. We have GPS planning tools. We have the ability to look at our local DZ and whole Earth capability moving around to all these drop zones. We have the LZ situational awareness opportunity that is no longer where is the aerial posted on the wall of the drop zone. I'm going to find that thing first to figure out what I'm going to do. I can now pull it out and look and say, okay, I know where I'm at in space. I see the hazards. I see where I'm supposed to be. I see what the runways look like. I get an orientation and the ability to start my pre-planning and my jump before I even go. So flight planning and then the debriefing, obviously, of that plan is now pervasive in our coaching experience as an institution, and that allows us to bring out other theories and principles about where we should be in space in relation to various wind conditions that really changes the game, okay? We've also been able to take that GIS data and create animations to help relay principles to the students. So if we look at this video, we've got our animation tool that we've developed as well, which is an amazing piece of technology. This is Joe Jumper on his base leg. and he's making a correction that's visible and obvious with a flat turn to open up the pattern until he starts seeing the visual picture he needs to arrive at his final glide slope to put him on target. So not only the use of the animation and building that technology with all the computer graphics and abilities that we have now, but embedding that into GIS data to teach people what they need to see before they jump. Okay, so that is Google Earth and GPS planning. Next technology is this GPS capability that once the government's opened up those satellites to us, all these tools started getting developed. And this was one of the first on the market, FlySight, and we were very fortunate to get involved. My teammate Jay was integrally involved with the developer Michael in not only the device and what it did, but more importantly, how we could process data from it and use that data to help us become better pilots. The viewer that you see in the lower right was largely influenced by what we needed to know and what we needed to be able to process. And the ability to see where the student is in space and what they planned versus what they actually flew, right? That's a biggie. When we get to the high performance side, obviously we could just totally geek out on all the performance variables, vertical speeds, horizontal speeds, turn dynamics. It is the standard now in the canopy piloting world. If you're not analyzing your data and learning from each jump, you're not getting better. So this has been an amazing tool, and it opens that window of real data to validate our techniques and our theories. Like, I think this turn felt better. Let's go look at the altitude. Let's go look at the speed. Let's go look at these things. So huge tool that was able to take that GPS data and make it real. Now we're shifting over into the software side of the house. The ability to take and animate and combine this GIS data with real world calculations and real world values of the environment, wind variables, canopy performance data, and create a solution framework that allows us to be better teachers and also for the pilots to understand more before they get into the jump. We've introducing a new piece of software called Skylander that we're proud to be partnering with at this point. It's going to be in display in our booth later if you want to check it out. The developer's here, and I encourage you to come check it out. But it's an amazing piece of flight planning software. Everything I just said is up there, but the ability to show the effect of winds dynamically on the pattern and integrate that with the performance data. I'm going to play a little video here that kind of steps through how this works. It gives us a dynamic teaching environment with the student on the fly. Okay, so letting this run, you can establish the LZ, the target, the basic pattern that you're looking to fly. You can begin to manipulate the wind, its magnitude and direction, and you get a live effect on the pattern and its shape that's based on the performance data of the wing you're flying. You can shift this thing and show where the turn points modify based on as the winds come from different directions. If you have maybe a crosswind or a downwind final, things of that nature, it shows all that. And then you have the ability to turn it and provide specific 3D view of what that student needs to experience. Translating it into a teaching environment, now you can create scale with the grid and the distances that are on the ground that the jumper is going to need to kind of identify with. So pretty powerful tool that we're excited to start implementing. Okay? Next technology, the parachute landing assistant. Before I jump into this, I'm going to ask some more questions. What methods in the instructors in the group are currently being used to help the jumper picture and get a sight picture of their flare height? Because any examples that are currently being used? How do you teach somebody how high to start?
Height of the windsock.
Height of the windsock.
Staircase, walking up the stairs and getting the peripheral.
Yeah. Anybody else? That's a great one. Top of the porch, top of the trees. One system height. We've heard all these, right? this is the same verbiage that's been in place for 30 years, right? Nothing is changing about how we give the student a better view of when to start the flare. So are we getting better results out of our pilots using these same methods? Do we still have high flares and low flares happening? It's a better question.
Yeah.
Yeah.
I don't think we have as many as we did in the earlier days, mainly because instructors are getting more experience.
Right. The education's getting better, I agree. This piece of technology can become even a better tool to help our instructors and more importantly our students acquire this sight picture during the most high-risk jumps, which is their first few jumps where they're trying to acquire that sight picture that was, kind of mysteriously describing as height of the trees, top of the windsock, things of that nature. So we've got this tool now available that's been well proven. It's been in the market. I'm going to get to some of the stats here soon, but basically it's the only audible landing device available worldwide that we're available and aware of. It gives alarms for the beginning and the finish of the flare. It's LiDAR based. It's extremely accurate, plus or minus inches for both of those parameters, height of the flare and the second stage of the flare. And we're able to utilize Canopy alarms into the system as well that I mentioned earlier, so the student's getting information in the pattern, and we have the ability to log their flare data and use it as a debriefing tool to show them what they're doing wrong, okay? And I've got a pretty bold prediction down there at the bottom that I want to share, which is, I think, based on what we've experienced as a school with this device in our client base, that this device will become as common on all students within 3 years. And I can say that statement based on these facts, this data. The performance results are astounding. We released this thing in 2020 to the market. We've got 13,500 student jumps with live MFF first jump students. Course of instruction, this includes over 1,000 night jumps. We have one lower extremity injury in that environment, one broken leg out of 13,500 jumps. And to back that up, what that relates to is before the PLA, every course we had about 3 broken legs, even with the best training that we could ever provide and all the tools I've already described. We still had some injuries that happened, the high flares, the low flares, right? And that relates to about 27 injuries over a total of 9 courses. This represents a 96% improvement in safety, okay? Pretty impressive tool. The availability has obviously already been released out to the military. We've been using it for a while. It's U.S. Air Force tested and approved for the entire Air Force now. It's gone through a laundry list of testing by that institution and is now on the authorized use list available for all U.S. military. And we've got a plan to move this technology into the sport world and roll it out in 2023. It's going to be a phase-based approach. I'm sure there's going to be a ton of questions about what that looks like, and we can get into that later, but a really amazing piece of technology. I'm going to play a video to kind of give you an idea of how it works and how it sounds. I'm going to use Joe Jumper again as an animation tool to bring him in. First phase, and then another tone for the second phase. Here's a Silhouette 210, same device. And then a POV. Okay, I'm sure we'll have some more questions about that later, but that's the PLA. I will just like to emphasize that it is a parachute landing assistant. The name is key. It is a guide to take the student to the ground, and this is one of the things that is very important as we implement any technology, right? Okay, well, let's shift into the VR world. Skydive VR, Ronnie presented already several seminars on his tool here. It's another virtual reality software that is allowing for canopy navigation training in a virtual space. It's got multiple sport DZs worldwide. He's even got some military-based tools for hey-ho offsets and things of that nature. This allows him and the student to go through and plan and pre-jump scenario-based training and debriefing of those experiences based on various conditions. So we get that repetition, that ability to be able to go through and practice repetition in space virtually and gain exposure to things before we actually experience them. It's a pretty powerful tool, and more importantly, it allows for, as a coaching experience, a Canopy coaching experience. He's launched, there's a whole online initiative that the instructor basis of the Canopy Control world, we can now train virtually from anywhere, remotely, with our students and debrief their experience. So pretty cool, and looking forward to using that tool more as well as it continues to develop and help us. We have some full-fledged simulators on the market that many are aware of. Parasim is the gold standard, produced by Systems Tech. They've been around for years. They're the pioneering virtual reality simulator in the world. They also have free fall and canopy navigation kind of experience that the jumper goes through. 20 years out there refining the data, refining the experience. It's a good product for the student to, again, experience these kind of like scenario-based learning. And then the instructor's interaction with that experience. So it really brings that whole training arena together. And it's got, over 20 different parachute systems supported on it. It's got a gold standard military-grade software simulation environment, image generator that he's using that can put you anywhere in the world at any time, pretty much. So it's a really powerful tool for sure. And again, the why behind virtual reality is that we're integrating the experience of visual and tactile feel with the equipment and a little bit of the motion associated with that. Okay, next chapter in the simulation world is something we have been working on for about 5 years in Flight 1 Tech. This is the S1M Simulator 1 Military. This is what we believe to be the world's first dynamic virtual parachute simulator. It is robotic, multi-axis, has a full suspension system, allows the jumper to move on all 3 axes of motion, pitch, roll, and yaw. You fly it like you fly a real parachute with toggles, harness, risers, body position. So it's a real world experience that we're trying to emulate there. We get real world G-forces that the jumper experiences because of the dynamic movement. And we've added a 4D kind of relative wind experience. So we have wind in the face that varies and moves and modifies as the system changes airspeed. So the big plus behind what we're experiencing with this system is that when you move the jumper through space, and he's not just hanging there and looking through virtual reality. How many people get sick as soon as they strap on a virtual reality goggle? My teammate is like, within seconds, he's sick, right? How well will you learn as a student when you start feeling motion sickness? It goes like this. Nobody wants to learn when they want to throw up, right? What we have experienced and what we've worked towards with this design is when you are moving through space, your inner ear is moving, your brain thinks you're moving, and so you don't get sick. Motion sickness goes away, if not extremely reduced from the normal VR experience. So that's huge. We've integrated with the latest VR software technology, and I believe this is going to be sort of like our future wind tunnel of canopy flight, okay? The most important reason why behind this design is because we want to train the jumper, the student, the way we fly. We want it to feel good. Everybody remember, who flew in the original wind tunnels that had big DC-3 props spinning around? What kind of suit you have to wear to jump in that thing? Big, huge balloon suit. And then you go to the drop zone and strap on your normal suit. The learning experience was not quite there, right? But as soon as the wind tunnels became faster, cleaner, we could start wearing our own suits, that wind tunnel suddenly became an amazing training tool. So if we can make the student feel real in this virtual experience, he's going to learn. So that's the why behind this. We're going to train as we actually fly. And we're really excited to show some video about this tool. It's been a long time coming, and it's in its full prototype stage. And we've got a full integrated experience. This is my teammate Jay flying in it. What's cool to see here is that he thinks he's there. He's flying in the body position that he would normally fly. He's looking around. He's feeling the fan on his face. He's cruising around. And we've got integrated software experience that I'll show you in a later video. And then we got my other teammate Brian, slows it down, gets the canopy slowed way down, and then starts cranking around on this thing, and you'll see the capabilities of movement that we're able to generate. The system can actually go a lot faster than this. We've had to detune it a lot to make it safe, but he's having a good time. And then we've got Ronnie, the owner and developer of Skydive VR, in the experience, his first real ride in a real simulator with his own software, and he's coming into landing there. And he was pretty blown away by the experience, so that was a good endorsement, if you will. Everybody who's flown in this thing that we've put in it already has been pretty amazed by how real the environment is, so we're really excited about it. It's patent pending. We've got our patent coming out in May this year, so we felt really good about sharing what we've got going. And the landing still is a little challenging, obviously, when you have the goggles on. So we'll take some questions on that later, if there are any. And I'll just sum up everything with this kind of some closing statements. Obviously, through these technologies, our Canopy Control Training timeline is continuing to show evolution, and it's showing a learning curve of improvement, as you mentioned, sir, right? We've got a toolbox of learning available to us as coaches and as a society, and as we add technology, we add more arrows to that quiver to help the students get better quicker. And that educational experience and tying the technology to training is key in bridging those gaps, right? The students are definitely having an accelerated experience because of these technologies. And the attitude of a student, right, being curious, is where we all kind of need to be. So I'll just sum it up by be curious, be open to new technologies, even if you learned by some guy on the ground that was waving flags around, right? And that kind of mental attitude will help us continue to evolve and keep ourselves safer and safer as Canopy pilots. So.